Today's note-taking guide is on domain and range. This is section 5.6 of Math 2. Before we get started with domain and range, I just want to review really fast how to graph an inequality, because if we can graph an inequality and see how it looks on the graph, then we're going to be able to find domain and range easier when we find a special notation called interval notation. So this right here, x is greater than or equal to 3. What I'm going to do is I'm going to start out with 3 on my number line. I'm going to put an open circle there because it's not equal to, and then I'm going to shade all my x's are greater than 3, so I'm coming in the positive direction to the left, to the right. Then again on this bottom one, x is less than or equal to negative 3. So I'm going to put negative 3 on my number line. At negative 3 this time I'm going to have a solid dot, and I'm going to graph all of my x's that are less than or equal to that. So I'm going to go to the left because my x's get less than to the left. So again, this is what we call over here inequality notation. These were the graphs. And then what I'm going to do today is show you how to do what we call interval notation. So just like we had when we had an equal sign there, we used a closed dot on the graph. When we have an equal sign and we're using interval notation, we're going to use something called brackets, and I'll show you how that works in just a minute. If we have a not equal to sign, just like we did when we used the open circle, we're going to use parentheses in what we call interval notation. So just to jump down and look at what we're talking about here, this graph that we did up here is now an example down here. X is greater than 3 is graphed here. This is inequality notation, graph notation, and I'm going to write interval notation. So what I'm going to do is I'm going to look and see how far to the left my graph went. My graph went to 3, but was it equal to 3 or not equal to 3? Because of the open circle, I know it's not equal to 3, so I'm going to put a parenthesis there. And then I'm going to look and see how far to the right my graph went. Because my graph is going forever, we call that infinity in math. I don't know where infinity ends or what it's equal to, so again, I'm going to put a parenthesis there. So in interval notation here, this representation of the same inequality in graph here would be 3, infinity. So again, over to these examples. These examples are the exact same thing. The first one is the same one that we just did. So we decided this would be 3 to infinity because the furthest most left point I have is 3. The furthest right point I have would be infinity. Both are parentheses because they're not equal to. This next example, when I look at x is less than or equal to negative 3, if I look how far left my graph goes, my graph is going towards negative infinity. It goes forever in that direction. It's negative, so negative infinity. I don't know where negative infinity's exact value is, so I don't know that it's equal, so I have to use a parenthesis. And then how far to the right does my graph go? My graph goes to negative 3, and I'm going to use a bracket for that because it is a colored in circle and it is equal to right there. This next example, x is less than 0. I'm going to put 0 on my number line. And I'm going to graph this. X is less than 0 is going to be an open circle because there's no equal to sign. Less than goes in the negative direction, so this direction. When I do my interval notation, I'm going to look how far left my graph went. My graph went to negative infinity. I'm going to use a parenthesis because I don't know where that ends, that exact value is. And then how far right did my graph go? It went to 0. Because it's not equal to, it again will be a parenthesis. Then the last example here on interval notation, I'm going to graph x is greater than or equal to negative 2. At negative 2 on my graph, there is an equal to sign this time, so I get to do a solid dot at negative 2. And I'm shading all of my x's that are greater than negative 2, so I'm going in the direction of the right. When I write my interval notation, I'm going to see how far to the left I went. I went to negative 2 to the left, which is going to be a bracket because it's equal to. And how far right did I go? Positive infinity with a parenthesis. This chart down here shows you a whole bunch of different ways in order to write this. If you have an open circle and an open circle, you're definitely going to have parenthesis, parenthesis. Open circle, closed circle is going to be parenthesis and bracket. So this is a great reference sheet to just remind you how to write your interval notation. All right, so why do we need to know how to do interval notation? It's so we can find our domain and range. If I wanted to tell you what domain and range, or how we would find domain and range, I would explain it to you as looking at your graph from left to right. And when we look at our graph from left to right, we would look at the x-axis because the x-axis moves from left to right. So I just want to put a note here that you're looking at the x-axis. Then what is the range? The range is when we look from the bottom of the graph to the top of the graph. Another way to say that is how low does it go to how high does it go. But regardless of which way you think of that, if we're talking about up and down, we're talking about the y-axis because it's the axis that moves up and down. So what we're going to do here is we're going to look at this graph and we're going to write the domain and the range in interval notation. Remembering that domain is how far left and how far right we went. I'm just going to look at this graph and I'm going to mark on my graph how far left it went and how far right it went. It went all the way left to -6 and all the way right to +5. Then I just need to decide if it's brackets or parentheses. Well, over here at -6, it's got that solid dot there, which means equal to. Because it's equal to right there, I can use a bracket. Then I'm going to come over here and I go all the way to 5. 5 again has that equal to dot there, which means I can use a bracket on this side also. Now I want to look at range. Range is how low my graph goes to how high it goes, or the bottom of the graph to the top of the graph. When I look how low my graph goes, this is its low point right here. When I look at how high my graph goes, this is its high point right here. As you can notice, I'm referencing the y-axis this time because on range we reference the y-axis. So the lowest point that my graph went to was 1. The highest point that my graph went to was 6. Now I'm not 100% sure if it touches here exactly equal to 1 or if it touches exactly equal here to 6. So I like to put parentheses there when I'm not sure. But if you think that you're 100% positive that it touches there, then you're welcome to just put brackets there. So in this box over here, it asked me the domain and the range. I just wrote them over there, so I'm going to transfer my answers over here to where they belong and just keep them there. 2 more examples here and we're done. We're going to practice domain and range here. We're going to do domain first. Again, remember domain is left to right with our parentheses and brackets. So how far left did I go? I went to -2. Because of the open circle here, I know it has to be a parenthesis. Then how far right did I go? I went over to 7. And because of that closed circle there, it's going to be a bracket. When I look at my domain, I looked left to right, but when I look at my range, I have to look bottom to top. And when I look bottom to top, I have to reference it to the y-axis this time. So if you can see, I'm drawing my lines over to the y-axis. How low does my graph go? My graph goes down to a -1 with parentheses because of the open circle. And it goes up to a +2 with brackets because of that closed circle right there. All right, one last example of domain and range here. This time we have some arrows going on. If we remember what arrows mean, it means that it follows the same pattern forever. So this pattern was the pattern of the absolute value graph, but we went over 1, up 3, over 1, up 3. So we'd be going over 1, up 3 forever in that pattern. So when we look about our domain, we know we're going over and up still, which means we're going to be going over forever. So our domain is going to start at -infinity and it's going to end at +infinity because it's going forever left and right. Our range, on the other hand, has a definite point that it starts at. It starts at -2. I know that's a vertex point of my graph, so I know that's going to be a solid dot there. And then I know that it goes up forever following that pattern, so it's heading up to infinity. That's note-taking guide on domain and range, 5.6 for Math 2.